He's always insightful in what he provides. So, without ado, here's Max.
Hi guys. So today we're going to be quickly looking at the Olympic Mini Project. One, I think it's a very, very good lab because it assesses your knowledge and also it just gives you a little creativity so that you get to go bug test for the first time. You get to go kind of experiment, play with code, and actually go problem solve, doing the data science. So first of all, we always want to start with running this up top. When I did this at first, I was having nothing working, and the reason why was because I forgot to import a couple of these. So remember, run that cell first. So we're going to do a quick overview real quick. You got your data file, which is called winterathletes.csv. And you have athletes right here. I'm going to use athletes so that we can all be universal, keep it simple. Athletes will give us this standard table, which is just all the data from the Winter Olympics. So first, I basically set it up so that we have a little something for each question and a little tip and possibly a little more extra useful stuff. So for the first question, you want to isolate age. So let's scroll down here to question one. Okay, what is the earliest year in the Olympic? Oh, okay, I might have used a different lab by accident when I was preparing this, but regardless, okay, what is the earliest year in the Winter Olympics data set? So if we were to do that, I think this one's actually, very simple, easy question to start with. What are we looking at? We're looking at year, year falls right here, and then we can do a dot sort function, like you're definitely used to doing. So, if you need help, you could probably look back into probably lab 2, lab 3, you'll find something there. And okay, number 2, I think this is where I'm starting to get back into sync.
Yeah.
So basically, number 2 is examining the age of all the Olympians with a histogram. And what do we find? So we're going to look at something real quick right here, which is the example that I accidentally provided for the wrong question. But right here, if we just look at the Olympic athletes and look at the column called weight, we're going to find that there's a whole bunch of numbers and a whole bunch of things called NaN. NaN stands for no associated number, I think, or something along those lines, or not a number. So basically, these are string values like weight right here, and they're not good because you can't add them, you can't divide them, and if you try to do stuff with NaN values, it comes up very, very icky. So right here, I have a check. You can use a check np.average table.column data like I should say age or weight. And if we do this line of code right here, so actually let's just copy it and paste it down here. So np.average table. So our table is called athletes. Dot column data. So we'll look at the column. For the sake of it, let's just look at age, or we'll use weight because we have this up here. Sorry for the confusion. But,
Yeah, that's good. Very good
so we'll
example.
use
Yeah.
weight, and it's going to come up with a huge error, and you'd be like, "Why the heck? The column weight is all data values." Well, the issue is you have a whole bunch of these nans, and because you can't average out a string, it's going to come up as an error. So let's get rid of that real quick. But down here, we look at this, and I have a little something called clean data, where it's athletes except weight has to be above 0. Now, I just set that as an arbitrary value, but basically what it's saying is all the values in this table athletes is going to be compared to the value 0. And if it's a string value like NaN, the computer's going to say, well, that's not a number, and therefore it can't be above 0. And because of that, we're going to get rid of all these NaN values. So if we look at here, athletes.where weight are above 0, it gives us all numbers. There's no NaNs. And the way we can check this is by using that little function. And let's run that. Oh,
Well, you might have flipped your
I flipped
table
that real quick. My
with,
bad, my bad.
yep. But it's good to see these because these are very common, you know, mistakes
Remember,
that all
everyone
of
makes
us make.
mistakes. We're not perfect.
Yeah, and that's the way data science is done. It's what you do with the mistake and what you learn from it is really Yeah.
Okay, so there we go. So if we look right here, we did clean data, which is just the same table, athletes up here, except only with weights that are values. And if we run this little code, np.average of this table, where the column is weight, we see that the average weight in an Olympian is 70. So I'm assuming that's probably in kilograms because that's very, very light for an athlete. So for number two, we'll use the .hist function so that we can examine the age of the Olympians. And if you clean your data, you can get a histogram because all the age of the Olympians that are displayed are going to be legitimate ages that are values, numerical. So that should be your little hint for that. For number three, you got to create a 5 number summary. Now, I like to have my data points clean, and although you can use a function, which is really nice, the way that I originally did it is I did something like this: table with columns, and if you have a little parenthesis there, you can actually press enter, and you can start coding like that, so you don't have to make it one huge line. But regardless, I did a table, so it's got a column called max, which has the max, the min, the min, and you can keep going, standard deviation, et cetera, to get your 5 numbers that you need. Um, and you also have this right here, which is that's a way that you can get 5 num sums actually more efficiently that you might have learned in class, where you can use that and give it any table and any column, and as long as you have clean data, it will spit out a 5 number summary for anything. So I'd really recommend you learn how to use this. But if you're like me and you're willing to burn a little time, you can have a little clean table that looks beautiful. So we got a quick lesson that I want to hit that I think is really important for this lab. There's a function called group. And what group does is it counts every so for basically the column that's being analyzed, every blip that counts in that is counted. And here's what I mean. So every 32 kilogram athlete, well, there's only one. There's only one 34 kilogram athlete, and you notice it's probably because these guys are really, really, really light. And if we expanded out this table or we put it in a plot, we'd probably notice that it'd fall along a standard deviation because people tend to be average weight. Some people are really, really, really light, and I'm sure the people on the extreme other end are like the power lifters of the Olympics, really, really strong, heavy, bulky people. So that's just the thing you need to understand. So we have clean data, dot group, weight, every weight, and how many times it appears. Let's look at pivot now. What pivot does is it takes 2 columns from a table. And what it's going to do is it's going to say how many instances of data points in column 1 are attributed to data point 2. And I'll show you this more in action, but here's an example for now. So how many attributions of 1 are applicable to number 2? So how many times did each event happen for each team? How many times did each event happen for Albania? Well, we can just scroll right down and we can see right here. Well, it looks like they're not big into participating, but regardless, if we're looking at Albania and alpine skiing for women's, they've done it once. And yeah, that's how you pivot works. So for number 4, we're going to use a group function. Let's look for number 4. And it says right here, since a given athlete can appear multiple times, we got to look at the age distribution of athletes. And in order to look at that better, to make sure that we don't have repeats affecting the data, we can use this right here. And this is a given piece of code because it's a little compact. It is a little complex. But if we look right here and we look at what happens, we see that we're starting to see every name being given weird values. And the reason why is because certain things you can't really average out, but nonetheless, we're getting the number of times each athlete does appear, which is important because we're differentiating um, by independent athletes. So if we look right here, we can use this command, group, and then after that, we can do a little analysis. For number 5, we're going to look at a 5-number summary of data. So remember, we did a 5-number summary for I think either number 2 or number 3, and we're going to be using those same functions down here. So first, you need to understand that cleaning data is the most important step of all data science. As someone who's done multiple projects myself, I could tell you that most errors happen because of some nan floating in there somewhere, or some string or some row that doesn't add up to the total amount. And your goal is to pretty much sort this out so that you can isolate the important data. So right here, what I did was I did medal as athletes, except only where people did win medals. So we're just not looking at the medal winners, and we just took out a whole bunch of clutter that we don't need. After that, we can look at 5-number summaries for each medal type. So now that we have medals isolated, we can do a pivot function. Now, I'm not going to give you the exact answer, but here's a little hint. If we can pivot team and medal to see how many times each medal was awarded to each team, what would happen if we did the opposite? Just a thought. Think about it.
Hmm. Hmm.
So, for number 6, we got to find the top 5 sports in terms of the number of athletes. For this one, I'd use sorting alongside grouping, because sorting will happen in order to find the top 5. Remember in lab 3, I think you did top 5 of this, top 5 of that, least this, least that. So you'll be sorting this table to find the top values of something. And also you'll be doing grouping because you're counting the number of times each sport pops up. So by doing that, hopefully you should be able to find the top 5 sports in terms of the number of athletes ever. And you'll want to put in a markdown right here. Is this what you expected? Just a little analysis. We look at it when we grade, and we want to just see what you're thinking. Why do you think the data would end up this way? Does that fit expectations? Go against expectations? Why could that be? Just think about it. We just want to see the thought process. For number 7, we look at, similar to number 6, the top 5 sports that awarded the most medals, but this time we're looking at Lake Placid, New York in 1980. Now, I give you a massive hint because I guess a lot of people don't watch the Olympics and aren't familiar, but I had to state Olympics only happen in one city every time they occur. So I'm just going to say if the Olympics only happen once in 1980, and there's a convenient column called year, we could possibly do a little dot where function to make things a lot easier to look at. Just saying, but it's very similar to question number 6. I also gave you another example of just let's see, of just a dot pivot command. So remember that if we're looking at the top 5 sport, or here I have sports and medals, but instead of analyzing a pivot of sports and medals, what if we looked at oh, we are looking at sports and medals. Oops. My bad. I gave you sports and medals, but you're going to have to sort out for the specific year by which this happens and specific data set that you need to sort for. So as I said, in the data science, you're sorting for a specific data set. In this set, you're clearing the clutter to get to Lake Placid, New York in 1980. For number 8, it's a challenge question. And for these, once again, we just want to see what you're thinking. So you don't have to answer this question, but we want you to, in a markdown cell, and by the way, here's a markdown cell. We can type whatever the heck here, and it just does that. No code happens. But we just want to see you put in here what you think you'd do in order to solve this question. So I might say, based on this, I would sort for host countries and see their medal counts, compare them against other countries that weren't hosting that year and their medal counts. Possibly something like that. We just want to see a little thought process. We don't actually have to have you sort this out because that is a very complex analysis. For number 9, they actually give you the code. So athletes.group year, plot year count, and here it is. And basically what we want to see is, what is the trend? What is that? Well, tell us, put it in Markdown. For number 10, we're going to plot the medals per year. Now, look at this right here. If we group by sport, this is what we get. But if we pivot, we can actually get something that can be plotted. Because what would happen is we're going to get a whole bunch of data with a y-axis that's shared, which is a year. So by pivoting by sport and year, we have a year y-axis that we can use and then plotting. So I think for this one, you can use grouping to find this one if we group by medals won by year. Or if we want to do something like this, we can use a pivot to find the medals won by year, except we'll actually get more specific data this way. Either or, both possible medals to find a plot of medals by the year. For number 11, it is very similar to number 10 minus hockey. And after you do that, we want you to answer the effect of why hockey actually affects the medal winners so much. Oops, that is a typo. But you're going to notice that the results are very different. And you could just think to yourself, okay, why could this be? Put in a markdown and we'll see. Number 12 is you're going to plot an overlay of gold, silver, and bronze medals. So up here, we plotted medals in relation to year. Now down here, we're plotting each medal in relation to year. Now remember up here when I showed you how a dot group gets you kind of less specific data, but dot pivot gets you a lot more specific data. Like here we have how many times each sport was played. Right here we can see how many each sport was played by year. That's a massive hint. That should help you a lot with number 13. I also wanted to just show you how quote unquote overlaying data works, because that sounds very scary to someone who's never done coding before. And I'm just going to show you how very simple it is. So I'm from Japan, so I'm going to use a little data from Japan to kind of just see what my country's like. So we can sort first where the team's Japan. Okay, this is only data from Japan. And what about we just see the data on the country and its genders by the year? So I know that Japan was a pretty sexist country, so I'm just making the assumption that women are probably going to be less common in the earlier years, and we'll just see. So we can run a pivot of sex by year. So remember, how much of this is attributable to this? So how many men are attributable to each year, and how many women are attributable to each year? And data is only taken in F and M genders. But regardless, what happens is, so we take this and it creates a table where there's a year, which we can use as a y-axis, and these two data sets, F and M, which we can use as X values. So if we take this table and plot it by the year, these values are going to be compared against this year. Y, X, Y, X, Y, X. It might be a little weird when you're used to seeing it X, Y, but that's kind of like the format of which will result in this plot down here. And as we can see, the females and the males are overlaid in this plot. We have one line for each because each was attributable to 1 year. And down here we have an extra sample. So let's just say we want to run an additional column. I just did the same table or the same table that made that plot, and then just throw an additional column with an extra table column called sample and just a whole bunch of data. It's an exponential function, and as we can see, it's an exponential function, goes up, and it's a plot of 3 lines overlaid. So 14, I was having a little struggle because I didn't want to give you guys the answer directly. But here is my little hint. Um, I was struggling a little bit with np.append. Dr. Smith, if you'd like to um, say a little something about it, we can look into it.
Hmm. Hmm.
But I was having a little issue with append. So basically, what I found was um, we're going to be sorting right here. So we can start with looking at US and Norway. And we're going to be doing different things to each data set. So if we look here, we can see a pivot of the US's metals won by year. And down here, we can see a pivot of the US's metals grouped by year. Take this out. Uh, I don't know what I did, but I don't know where I was going with the example. My bad. Regardless, you got to have or you got to compare like a grouping function to a pivot function, one of which is easier to use. So in this case, I would say you'd probably want something like a group function where you have um the US and the Norway metals by the year. So it'd be by the year. It wouldn't be how many of each specifically, but it'd be how many total per year of each. And if you really need to, what you could do is you could make a separate table to get your data sets plotted like this. So what I personally did was um, I took this data set of Norway. I took this data set of the US. This append step did not work for me. So what I would probably do is I'd do something like I do something with like table with columns and then a year, which we can use as a y-axis. And then probably something along the lines of the years by which America and Norway were playing the Olympics. So we could say, just as example, and then we can just enter the data set from there. So if we have years, these years should be universal. The counts should be universal according to the year as well. So for here, I could say the next data set that we're going to use is USA. So remember when we create a table, we want to start with column name, data set. So the next column would be USA, and then it'd be and then we can go with USAP, which is this table, dot column count, which is this data set, which is the number of medal winners per year. Now, I need to sort this data a little bit better because there's a mismatch in row number here, which will cause me an issue if I were to create a table as of now. But when you do go about creating your table for or your plot for number 14, make sure that they both have the same number of years that they're using as a y-axis, and the x data points can be 0, but you might have to manually put some of those in. And remember, that's just clearing the data or cleaning the data so that the computer reads it and graphs it properly. And the use of dot scatter for number 15. So basically, you're going to have an X, which is Norway, and a Y, which is USA. And by using a plt.scatter of one against the other, we can basically see a comparison of how the US and Norway would be on a scatter plot of by medal winners. So I apologize towards the end. I had a little bit of a I had to wrap up the ending a little bit, so I couldn't clean up this data perfectly. But regardless, I hope to have shown you decent usage of the skills that will happen on this lab. The biggest ones that you got to focus on, as I showed significantly earlier, are grouping and pivoting. And if you can use those effectively, the lab should be a breeze.